Hey there, and welcome to Play Noggin. I'm Julian, your brains player 2. If you're a normal person, at one time or another, you've looked up into the night sky and wondered if we were alone in the universe. Prolific game developer BioWare made a killer trilogy of games called Mass Effect that explores this idea in great detail. Maybe you've heard of it? We did a whole episode on it. Now, there's an all-new chapter, Mass Effect Andromeda. The original trilogy was famous in part for the different choices a player could make, which ultimately led to 3 different endings, each of which had several variations, meaning a direct sequel would be a mess right from the start. The newest installment sidesteps this issue in a clever way. After Mass Effect 2, and prior to the beginning of Mass Effect 3, a group of humans were sent into deep space in an effort to save the human race. People weren't so sure if this whole Reaper thing would just blow over. After voyaging for hundreds of years in suspended animation, you and your fellow travelers are unfrozen in the Milky Way's nearest galactic neighbor, Andromeda, which is just a hop, skip, and 2.5 million light years away. So you're still in the same universe, literally and figuratively, you're just in a different section now. This allows the developers to tell a brand new story without negating anything that might have happened in your original trilogy playthrough. You chose destruction, well, I chose synthesis. Now, how do we reconcile that? Easy. Everything is still canon, the events of the first games just take place a long time ago in a galaxy far, far away. Wait, let's find a less litigious way of saying that. A significant while ago in a star cluster a good distance from here. Okay, I think we're covered. So, say we find ourselves in a situation similar to the one we found in the original Mass Effect trilogy. Maybe we're not threatened by Reapers, but by something a little more insidious, like horrific climate change. Could we pack our bags and find a new home among the stars? How realistic is the idea of finding even one other habitable planet out there? The events of Mass Effect Andromeda actually have a particularly pertinent ring to them today. Astronomers recently discovered 7 new exoplanets, a word that just means a planet orbiting a star other than our sun, in a star system not too far from here. Any of those planets could, in theory, be able to support life. They're all orbiting a star called TRAPPIST-1 in the constellation Aquarius, 40 light years away. That's 378 trillion kilometers, or 12 parsecs, or 1 Kessel Run. Okay, nobody share this video with Disney's lawyers. Scientists believe today that there are actually a great many more habitable planets in the universe than we once thought, and you don't have to go all the way to another galaxy to find them. Current research suggests about 1 in 5 stars with characteristics similar to our sun have at least one planet in the habitable zone, a distance that allows for liquid water and thus life as we know it to exist. Now, this doesn't mean we're super likely to run into a bunch of Asari jetting around out there, but it does mean that life in a form we might recognize is possible elsewhere in the universe. One study estimates that approximately 8.8 billion habitable Earth-sized planets exist in the Milky Way galaxy alone, and each of those lies within what is known as the Goldilocks Zone, not too hot, not too cold, but potentially just right for life. Now, if you think that sounds like a ton of potentially habitable planets out there, you'd be right. We're talking about a near infinite universe, and any number times infinity is, well, you get the idea. Mass Effect Andromeda represents that scale by giving you large planets to explore, some of which are as large as the entire playable area of Dragon Age Inquisition. If you haven't played that game, just know, that's a lot of playable space. Since we're not working with the sort of tech that Mass Effect's super advanced scientists have access to, how do we determine if a distant planet is potentially habitable? Well, first we need to find them. There are many tools for hunting exoplanets. The Spitzer Space Telescope observed TRAPPIST-1, the dwarf star with the 7 planets. Wait, is that a Disney reference? I can't even tell anymore. But the biggest name in exoplanet hunting right now is the Kepler spacecraft, a special mission launched by NASA just to find extrasolar worlds. To spot planets, Kepler uses the transit method. Essentially, the massively powerful telescope observes the minuscule reduction in light that occurs when a planet passes between us and its star. When this transiting occurs at regular intervals, we know we found a planet. Based on how much light is blocked, we're able to tell how big the planet is. The length of time between transits shows us the planet's orbit, and thus its probable distance from the star and its temperature. An Earth-sized planet the right distance from a star with hospitable temperatures doesn't mean the planet has life for certain, but it opens the door to that possibility. So we're able to identify potentially habitable planets, but how do we determine a planet is actually habitable? We can't just send a team down in a Mako, now it's called the Nomad, sorry EA, and have them collect samples. I mean, that would be cool, but we're just not there yet. Fortunately, NASA has figured that out too. In order for a planet to capably support life, it must possess extended regions of liquid water, conditions favorable to the assembly of complex organic molecules, and energy sources to sustain metabolism. This definition could change if we someday discover life that is able to thrive in the absence of liquid water, but for now, this is what we're like, so that's what we're looking for. There are other prerequisites too. A planet needs to rotate on its axis and revolve around its star, and ideally it should tilt similarly to Earth, giving the planet seasons and creating an environment more conducive to evolution. The planet needs to be rocky, not gaseous, so we can actually, set foot on it, and it also needs a molten iron core to generate a magnetic field. This will protect life from harmful radiation and keep the atmosphere from being stripped away by stellar winds. And it'd be nice if the gravity wasn't too high so our bones aren't crushed, though we would probably adapt to lower gravity planets. There's more, but you get the idea. The more Earth-like a planet is, the more confident we are it could support life. Scientists are particularly excited about the discovery of the TRAPPIST-1 planets because they no longer have to speculate about whether those sorts of planets exist. They're out there, and now we simply need to study them to find out what secrets they hold. If you want a taste of the future of space exploration, check out Mass Effect Andromeda. It launches on March 21st in North America, and EA let us take a sneak peek at the game, and it's everything we'd hoped it'd be. We got to run around on some huge and gorgeous exoplanets, but that's literally just scratching the surface. Thanks for watching. Please be sure to like and subscribe to Play Noggin, and please share this video with your Mass Effect loving friends, so long as they don't work at Disney. We get to do cool stuff like talk about games before they're released because we're growing, and it's all thanks to you guys. Check out our first Mass Effect video here, and if you have a suggestion for a game we should cover, drop it in the comments. And don't forget to keep on playing.